recording. So Emily, we're recording this for you, so hopefully you watch it. It's an hour long, so you can fast forward just to the ones you need to watch. That's what you could have done, John. Just fast forward the ones you needed to watch. You know? You could have. Okay, so lesson 44 was abstract rate problems. We're not going to deal with those. Did you watch the video on it? Yes, and do you see how hard they are? Did they seem hard, or did you get them?
I got them when I watched the video. Did some of the problems, but not all of them.
Yeah, they're pretty hard. They get worse because they get all mixed together. When you have each type separated, you can do them, but when they're all mixed together, they get really hard. So let's just start. Yeah, so we're not going to worry about this. Let's start with lesson 44, number 4 then. Okay, so they threw in some distance problems, like they haven't done that for a while, and then all of a sudden, I don't think they taught these, did they, in the lessons?
Nope.
Yeah.
Not that I remember now.
All right, I'm trying to get my pen to work. Okay, so here we go, lesson 44. Lesson 44, who asked for this one? Number 4.
I did.
Okay. When I printed it out, now my ink colors are down, so I can't tell what color they are. So 2 people, John, you put 4 too, didn't you? John, are you still with us?
Yes.
Okay. Lesson 44, number 4. Didn't you put that one down? In his search for the fountain, Ponce ambled for 1 year at a leisurely pace, then tripled his pace for the next 10 years. If the journey was 3,100 miles, how far did he amble? Okay, so they're telling us the total distance for the journey. So it's one of these problems. Distance 1 plus times time, rate 1 times 1. Rate 1 time 1 plus rate 2 time 2 equals the distance. So it's one of those kind of problems. You can figure out the rate of ambling is equal to 2 times the rate of ambling equals the rate of, what's the other thing that he did? He tripled, the rate tripled. So you have to take the rate ambling times 3, not 2, because it's 3 times, it's tripled. Let me just redo that. The rate of tripled equals 3 times the rate ambling, like that. We'll do lowercase a. All right, that's that. What else do we have in this problem? The time ambling is 1, and the time tripled is 10 years. Wow, he's pretty good. These are odd and unusual problems, aren't they? Okay, and now once you get that in, then you just substitute it into that first equation up on the top. So this one would be rate ambling. Let's just rewrite this. Rate ambling, time ambling, plus rate tripled, time tripled, equals the distance of 3,100 miles. So rate ambling is rate ambling. Time ambling is 1. And then rate tripled is equal to time ambling, or rate ambling, 3 times rate ambling. And that was times 10, so that equals 3,100. And then you just distribute it all through, and you get the rate ambling equals 100 miles per year. And so 1 year would be 100 miles. Does that make sense, how this is set up? So your rate times times, because it's one distance, so you can set it equal to the distance. All right, and there's only 2 problems in this lesson. I told Emily that she could, she was supposed to put her problems on the help board so she could watch these. There's not many. Like, John, you have the most problems. Risa, do you not have trouble, or do you see his and they covered yours?
I only put the ones on the help board that I don't understand how I got that wrong, or I don't know how to do the problem. But if I know how to do the problem and usually get it right, then I don't put it up.
Okay. All right, well that makes sense. That's what you're supposed to do. Okay, 24. What is 24? All right, so 24, these are the kind of problems everyone seems to love to hate. They get worse in the next section, or a couple sections, a couple lessons down the road here. Let's just squeeze up here. This is number 24. We've done these since Algebra 1. Do you guys know that?
Really? Oh, yeah.
Okay, so you look at the chart in your book and you find 2 points that cross grid lines. So grid lines look like this, right? So you're looking for 2 points where the line crosses the grid line. I didn't do so good on that. Like, say like that. All right, so let me draw another line. So you would look for points that cross the grid line like this and this. And then you write down the points for those. So if you look at your book, you pick the easiest ones. So one of the points would be 0. No, it wouldn't be 0. It would be 20. They're counting by 2's in the bottom axis. So it's going to be 28, 26. So it's going to be 26 on the x-axis and 0 on the y-axis. So that would be one point that crosses right. It looks like the origin, except it's not going to be 0, 0 because the x-axis goes down by 2's, and so it's going to go down to 26. And then the other point that it crosses is at the very top of the line before it goes off the top of the chart, the point 37. Wait, this isn't counting by 2's, they're counting by 1's. So this is 28. 29, 28. This should be 28. Okay, do you guys see that? 30, 31, 32. Okay, so it's 37, 37, 500. John, do you see that? John, are you looking in your book? Okay, look in your book at the chart. Do you see it? The graph.
Yeah, I've seen it.
Okay, do you see where I got the points 28, 0 and 37, 500? There's a graph here like this, and it goes like this. It's easier if you just look in your book. So you have 30. Okay, you got your book now? 30, 32, 34.
Yeah.
Okay, 36, 38. And then this one would go 100, 200, up to 500, okay? All right? So you got that, and there's a line going down like this through there, okay? And so you find points that cross the grids. So right here you have this point. And that point right there, since this is 30, this is 29, this is 28. And on the y-axis, it's counting by hundreds, so this is actually 0. And then right across here, something like this. Oops, it comes down at 37. Right here is a point, and this is going to be 37, 500. John, do you see that?
Yes.
Okay, once you get there, once you get these 2 points, it should be really easy from there, because you get your slope. So it's going to be 500 minus 0 over 37 minus 28. So you just do the slope formula on 24. Let's see. So you're going to get 500 over 9, and that's going to be your slope. And that ends up being 55.56. And then you do your y equals mx plus b. So you pick one of your points, y equals mx plus b. So pick the easy point, this one. So you get y is 0 equals 55.56 times 28 plus b. And you solve that and you get b equals negative 1,555.68. And then you put it in the formula. You use the f equals 55.56 d minus 1,555.68, where the y-axis is your f and your x-axis is your d. That's why you use your f and your d, because this stands for fleas. F stands for fleas and D stands for dogs. So, all right. Neither of you guys have a graphing calculator, do you?
Well, I do.
John, you have one too?
Yes.
Hmm.
PI-80.
Yeah, do you guys have it with you?
Mm-hmm.
Okay, when we get to the next one, we're going to use, with a future lesson, we're going to use that. Okay, I know Emily has one. Right, Emily? Okay, here we go. Let's go to the next one. We have lesson 46. We're going into condition.
45.
Oh, I skipped 45. Okay, let's do 45 too. Lesson 45. That's what I have the book open to. This one is called conditional permutations. So these are interesting. And also two variable analysis using a graphing calculator. So we're actually going to use a graphing calculator. Did you try the problems using a graphing calculator?
Yes.
Did you get them?
My dad and I needed to put it on
Mm-hmm.
because in the beginning it did not have L1. It only had L2 done, so my dad put it around with the calculator and got it.
Wow, good job, John. Did you figure it out? Did you?
Those ones are easy.
Okay, so you figured out how to use the stat, because that would be the stat button. Okay, so you got those, yeah. Yeah, they're kind of fun. You just put the stat, you put your list in of the x's on the L1 and the y's on the L2, and then you just push y equals mx plus b or whatever it is, ax plus b, and it gives you the equation. It gives you the a's and b's, I guess. All right, so we don't have to do those. Now these ones are fun. I like doing these permutations. Permutations are arrangements in a definite order. So the book says they have conditions attached that make finding solutions challenging, and there's no formula that can be used. So there were a lot of examples. How many examples did he do in the video of the permutations?
He did a couple.
Yeah?
Yeah, just 2.
Okay. He usually doesn't do as many that are in the book. Okay, this is how I do these. It says, how many 3-digit counting numbers are there? So I always make these little slots. Does he make slots?
Boxes.
He does boxes? Okay, well,
He does boxes.
okay. Well, I like to do slots because they're easier to write than boxes. So, so I just do these slots. I think they're more fun. So how many 3-digit counting numbers that are less than 300 such that all the digits are even? So if you have your counting numbers, it's not going to actually, it actually is going to start with 0, but 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, those are your numbers. How many 3-digit counting numbers that are less than 300? So you have to start on your slot number 1. How many numbers can go in here that would be less than 300 and it has to be even? So that's how you start. You start at the most limited one. So you would look, can you put a 7 right here?
No.
Okay. You can't put a 7 because it's why?
Bigger than 3.
It's not less than 3. It has to be less than 3. And it has to be even. So there's only one number that you can really put here. What's the one number you can put here? 2. Because you can't...
No, you can put 1 there too.
No, because it has to be even.
Yeah, but the evenness of the number only counts on the last one.
Except it says that all the digits are even. Yeah, but usually you're right. Usually if it's an even number, it only depends on the last one. But this one says that all the digits are even. What, John?
In the book, they started out with the last box.
Well, it just depends, because if they're saying that the number is even itself, then you would start with the last box.
Oh, yeah.
But this one says all the digits have to be even, and the most specific one is the first digit. It has to be less than 300, so the first digit has to be 1 or 2. And you can't have 1 or 2 because 1 is odd. So you start with the most specific one.
This is 300. The counting number. How do they represent each other?
How do they what?
You say less than 300.
Yeah, like,
I mean, like one of these counting numbers was 100.
right, just one. They're just saying how many numbers out of this list of counting numbers, how many numbers, this is a number like it's going to be like 198, 188 or something like that. How many digits will work that are less than 200 or less than 300? So if you're having a number like, it's hard to explain.
I get it.
You get it? You can't have, you're trying to get a number less than 300. So which one of these numbers would work for the first number of those 3 digits? Well, you can't put a 0 because it wouldn't be a 3-digit number. You can't put a 1 because it's odd. You can put a 2 and that would still give you the first number less than 300. You can't put a 3 because it's odd. You can't put a 4 because it's not less than 300. So then we go to the next one. Now these ones they can repeat. Like you could have a number like 188. You're allowed to repeat these digits. Now sometimes they'll say they can't repeat, and that's a whole new story. But these you can repeat. So how many numbers are even out of this list? How many? 5. Yeah, sometimes you're like far away, John. 5. And then since we can reuse them, there's also another 5 that are even for the last digits. So you multiply these all together, the permutations you multiply, and so you're going to get 25. Yeah.
Isn't the first one a 2?
No.
That's question 1.
But you know, in the first place, you put a 1 there.
Yeah.
Right, because there's only one number that you can do. I'm going to do one in the book here real quick. Let's do, yeah, I'm going to do example 4 in the book. How many different 4-digit odd counting numbers? So this is example 4 in the book. We'll just do it real quick. He doesn't do the ones in the book, so you can always look at the examples in the book. So this one's how many different 4-digit odd counting numbers can be formed if no repetition of digits? So you kind of write your numbers down, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we want 4-digit counting numbers, and it has to be an odd counting number. So that's why they're starting with the last number, because if it's an even number, then the last number is going to be even. If it's an odd number, the last number has to be odd. So how many odd numbers are there out of this list? 5. So you put the 5 there. So you start with the one with the most constraints. So if this number is going to be odd altogether, you have to start the last number. I mean, it's going to be the same if it's even or odd, because there's 5 evens and 5 odds. So how many digit numbers are if they don't repeat? Well, we used one of our numbers, so we have less numbers now. So then we go back to the beginning. We need 4 digits. How many? You go to the first number now. Okay, you used one of your numbers, and you can't use 0. So how many possibilities are there for the first number? If you can't reuse the number. Yeah, there's 8. So say we just used 3 for the last number. We couldn't use 0 here because it would be a 3-digit number. So that means we have to get rid of another number. All right, now how many numbers are left for the second spot? Well, we still have 1, 2, 3, 4, 5, 6, 7, 8. We used 2 of the numbers. We still have 8 because we can use the 0 now. This one we couldn't use the 0, and we couldn't use one of the odd numbers. One of the odds. All right? So there's only 8 for this one. Now how many are left in the third place?
7.
7, because we just picked another number. And now we have 1, 2, 3, 4, 5, 6, 7. Because we can't repeat them, we have to cross them off. In the first one that we did, you can repeat them, so you don't have to cross them off. You can keep reusing them as much as you want. All right, so you would multiply all these together, and you would get 2,240. Lots of combinations, huh? Okay. Yes, I used to hate these, but now I like them. So there's hope for any kind of problems. You can learn to be a problem lover, even after you're a problem hater. Okay, 1, 5. Whoops, I'm on the wrong lesson again. No, that was 1. Okay, we are on 5. 5 is one of these silly distance problems. All right. Which one of you guys had this one? Who had this problem?
It probably was me.
Yeah, there's actually 2 of you had it, so this is a biggie. Okay, on a 24-mile trip to school, Brandon sauntered at a leisurely pace. Then he had to double his speed on the way back to complete his trip in 9 hours. How fast did he travel in each direction, and what are his 2 times? So we have the rates. So he had to double his speed on the way back. So he went to school, so we'll use the O for school and to. Rate times time equals distance out to school. And then we have the rate back, time back. I have a feeling there's more than one way to do these problems. But we'll just do them the way that the book does them. Because you could also say that rate out, time out, plus rate back, time back equals the whole distance. But we'll just do them the way that they have them. Okay, now we can say the rate back is equal to 2 times the rate out because he came back faster, so you have to take 2 times the rate out. And we have the time to school plus the time back from school equals 9. And both distances are the same. Distance to school equals the distance back from school. All right, do you guys get that? Everything clear so far? So you need to solve this equation for one of the times. So we're going to say the time back equals 9 minus the time out. And then we're going to go up into this formula right here. And we're going to plug in everything that we know. So we know the rate back, is 2 rate outs. So we're going to say, we're going to go up here. So rate back is 2 rate to school. The time back is 9 minus the time to school equals 24. Okay, it looks like I'm going to have 2 variables. Oh, we know the time. Let's see. What did I do here? 2, 9 minus time out. Okay, let's just keep going. You okay, Risa? Your house is really quiet today. What's the occasion?
Nothing.
Nothing? No one's doing anything today?
No, just school.
Just school? Okay. All right, so do they give us any more details here? Let's see, 24 started, then he had to double speed on the way back to complete his trip in 9 hours. Okay, so let's see, we have 18 to school minus 2 times the time out. The rate out, time out. Okay, so the rate out, this is the tricky part right here. See, rate out, time out equals 24. And because that's the distance, and here we have a rate out, time out too. See that tricky thing? John, you see that? John? Isn't it? Okay, do you see how you have a ROTO? You got this one, John? Well, good. Because this is kind of tricky because you're like working it and you're like, oh my goodness, I have 2 variables, I can't solve it. But if you look up here at the top, rate to school, time to school equals the distance, which is 24, so you can replace that by the 24. Is that where you got stuck, Risa?
I think so.
So if you add that to both sides, you get 72. So the rate to school would be 4 miles per hour. Whoops, my whole thing shifted while I was writing. And then you can just go and figure out the other parts to it. But this was the tricky part right here, just figuring rate to school, time to school is 24. All right, slowly moving along here. That was 5. Now we're going on to 9. Okay, so 9, someone put this in. Who put 9 in? Okay, but did you figure it out, John?
You know,
9 is the one where you use your calculator. What was that?
paper said that.
Your paper said you got it right?
No, my paper said I need help.
Oh, you need help. Okay. So in this one, to figure out how to work in your calculator, first thing you do is you push the stat button. I didn't make enough room. So you push the stat button. And then once you get to the stat button, you push edit, or you just push number 1. All right. And then what will pop up is it'll say list 1, list 2, like that. Okay. So you just start entering. So you just start entering all the x values, all the whole way across the top. So under list 1, you put 110, 120, 130, 140, 150, and 160. Then you tab. Did you do all that?
Now I understand it. I thought it was a different type of comment.
Uh-huh.
I see it.
Whoops, so I have too many numbers here. 82, 80, 92, 99, 105, 105, 113, 120. Okay, so you put these all in, and then you go back to stat, then you go back to stat, and then you say calc, then you go to calc, and then this is just in case Emily didn't get it. And then you go to and you push the number 4 for linear regression, or you can like tab down to it. And then you push enter. So you push enter, and you're going to get y equals ax plus b, and then you just fill it in. Y equals 0.769, like that. X minus 2.26, like that. And then you should put in the right letters for it. So your y is RH equals 0.769 dy minus 2.26. All right, you guys get that?
Mm-hmm.
Yeah, so these, as long as you have a graphing calculator, we can do all these. John? John?
After you get A and B, then you just substitute that into.
Yeah, then you just substitute it in. My calculator doesn't give me an R value. Does yours?
Ours is an R and then R squared.
Oh, mine must be delayed. So the R just tells you how close it is. The closer it is to 1, the better. So this one apparently gives you an R value like of, let me look it up in the book here. This one gives you an R value of 0.99. So it's giving you the R value equals 0.9944. So that's really close to 1. So that's telling you that your line is a really good estimation of these points. So if you plotted this point, this line would be what would best fit all those points. It would go right through the middle of them all. It's kind of cool feature. I mean, if you knew that, you wouldn't have to do like in the last lesson, you know how we did that one where we like picked 2 points on the grid lines. You could just enter it into your calculator. Yep, all that Algebra 1 stuff is unnecessary because of the calculator. Takes care of it all. Okay, 13 and 21. 13. 13 is sketch the function. Nobody ever likes these. And the book does them really weird, so it doesn't help you at all. So I do them really simply. This is called an exponential function because the exponent is a variable. So it's going to increase rapidly. As x increases, the graph is going to increase. So if it's fractional, let me see what the graph actually looks like. If it's fractional, it's going to go up this way. If it's not fractional, it's going to go that way. So all you have to do is you just plot a few points, you make your x and y table. You don't have to do whatever the book did, the answer key, they broke it into 2 parts. You don't have to do that, just pick numbers. So if I put a 0 in, what are we going to get for the y? I'm making you think for a second. If we put 0 in for x, what do we get for f of x? Y and f of x are the same thing. Yes. Y and f of x are the same. So if you put 0 in for x, you're going to get 1/2 to the 1 power, which is 1/2. All right, see that, John? What? You split them up? That's because you're looking in the book, because no one in their right mind would split them up. Don't look in the book. Just substitute your numbers in. You don't have to split them up. So if I put a 1 in, let's put a 1 in for x. So it's going to be 1, -1 plus 1 is 0. So 1/2 to the 0 power is just 1. See how easy that was? Okay, let's do one more just for fun. What number do you want to do?
-2.
Okay, well I heard a -2 and a 2. So if we put -2 in there, we're going to get -2, which should be +2, plus 1 would be 3. So it's 1/2 to the 3rd power is 1/8. And if we put the +2 in there, we're going to get, if we put a +2, we're going to get 1/2 to the -2 plus 1 equals 1/2 to the -1 power, which equals 2. All right. You really don't need that many points if you know it's an exponential function. So you draw your graph. There's no way it's ever going to be 0. There's nothing you can put in for x to get something that comes out to be 0. So it's never going to hit the x-axis because there's no way it could ever be 0. So we just plot our little points. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2. Okay, so you get 0, 1/2, which should be there. 1, 1 is there. It's exponential, so you know you can already see it's growing this way. And it's going to come down. It's never going to hit the x-axis. So we're going to get -2 and 1/8. The fraction is just going to keep getting smaller and smaller and smaller and smaller, but it's never going to hit 0. So that's that. And then we can put the 2 in, and we're going to get a 2. And from here on out, it's going to grow exponentially. So it's going to be 2, and then it's going to be 8, and then it's just going to shoop like that. So that's what it's going to look like. If it was not a fraction right here, it's going to go the other direction. So that's kind of fun. Okay, those aren't hard because all you need, really, you just need 3 points, and you have to recognize there's a variable in the exponent, so it's going to be exponential, and it's going to look like that. The only way it's going to shift up and down is if you have like a +1 here or a -1, it's going to go up and down on the axis. Okay, 1321. All right, I went, where to go? Okay, number 21. All right, what is this one? It's yours?
Yes.
Okay, inverse function. So you have f of x equals 1 over x and g of x equals 1 over x. Your eyes can be deceiving. If I looked at them and I said, are they inverse functions? I would say definitely not. But then when you do it, they are. So the way you determine if something's an inverse function is you do f of g of x, and you figure it out, and then you do g of f of x and figure it out. And if they end up being x, then they're inverse functions. So let's do f of g of x. Easier said than done. So you say f of g of x. So you do this first, and then you substitute g of x is 1 over x. So I substitute that in. And then I take this and put it in for that x. I'm taking it to the f function, go to the f function, replace the x with 1 over x. So we say f of 1 over x is equal to 1 over 1 over x. I just replaced this x with what x is equal to. And then when you flip it, you would say it equals x. So that one works. Now we do g of f of x, like that. So we do g, f of x is equal to 1 over x, and you can see it's exactly the same thing. Then we take this and we put it in the g function where the x lives. So that would equal 1 over x, and if we flip it, you get equals x. So they are inverse functions. You have to get the x out, and then they're inverse functions. There's no negative sign anywhere.
It's supposed to be an equals.
Where's, yeah, I don't know, did something erase for you guys? All the equals.
The g of x.
This g of x right here,
Yeah.
does that look like a negative?
Yeah.
Sometimes they erase. It's weird. So it should be equals right here. Okay. Okay. All right. Lesson 46. There's a lot of there's not a lot of repeats on that one. So here we go. Let's go to the next one. All right. Lesson 46. And then there's only one for lesson 47. I don't know why that is. Did you guys not get to that far?
That one's mine.
No, I mean lesson 47. Like there's only one problem in lesson 47.
Yeah, that one problem's mine.
That's all you got wrong.
This is the only one I didn't understand what I got wrong.
Well, that's pretty good, Risa. Okay, 46, number 2. All right, here we go. We have 6 literature books and 4 math books are on a shelf. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 books, right? 10 books are on a shelf. Okay, take your house being quiet back. How many ways? What is that?
It's a vacuum.
Okay. 6 literature. Your house must be really clean. Because clean it all the time there. Okay, 6 literature books and 4 math books. All right. Now, how many ways can they be arranged if the math books are kept together and the literature books are kept together? So, the first way you can do it is you can have your 4 math books at the end and your 6 literature books in the beginning. Or you can have 1, 2, 3, 4, 5, 4. Or you could have your 4 literature books together, 1, 2, 3, 4, 5, 6, and your 6 math books together, right? Because they have to stay together. If you put the 6 in the middle, then you'd have 2 math books in the beginning and 2 at the end. So these are the only 2 ways that you can arrange it. Now, the reason you get big numbers for answers is the math books can be arranged. The literature books, you could have literature book 1, literature book 2, literature book 3, literature book 4, literature book 5, literature book 6, math 1, math 2, math 3, and math 4. So these literature books can be arranged. You could put 2 first and 1 second and then 3. You could put 4 first. There's a whole bunch of different ways you can arrange your literature books, right? You guys with me?
Mm-hmm.
Your literature books can be arranged in many different ways. So if you have, let's just talk about 3 numbers real quick. Say we have ABC. How many ways can ABC be arranged? Do you guys know offhand? How many?
Is repetition allowed?
No repetition, because if you're thinking about it, like if we're talking about, yeah, so you could have ACB, you could have BAC, BCA, and then you could have CAB and CBA, okay? So there's 6. Now, you don't want to do that. If you have like 6 different books, you don't want to have to write out all the combinations. So the way individual things can be arranged without repetition is just the number of items factorial. So that means it would be 3 times 2 times 1 is the different number of ways that those letters can be arranged. So if you had if you had all these letters like this and you had to figure out how many ways A, B, C, D, E can be arranged, it would be 5 factorial. That way you don't have to sit there and try to figure out all the arrangements. So the different ways that these literature books can be arranged, since there are 6 of them, would be 6 factorial, and the different ways the math books could be arranged would be 4 factorial. And down here would be 4 factorial and 6 factorial. So you can use your calculator to do factorials, or you can say 6 times 5 times 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1, like that. And there's 2 of these. They're going to end up being the same, so it's going to be times 2. So you can either find the factorial button in your calculator, which I think there is one, right? Did you guys find it yet? Did you? Anybody? So you're going to have 2 times 17,280, and it's going to be 34,560 ways that you can arrange your literature books and math books so that your literature books stay together and your math books stay together. All right, you use the factorials when there's no repeating, like when they're individual books, like obviously they can't repeat because they're all individuals. Okay, does that make sense to you guys? Yep. Okay. Number 6 is probably another distance problem. This one's exactly the same as the last one we did, so let's just skip it. It's the same. It's exactly the same where you have 2 rate times time equals a number. Rate times time equals a number. So it's the same thing. So we're going to skip that one. 14. 14? All right. John, did you forget this one? Did you? Okay, so number 14. This one is find the standard form of equation whose center is hk and radius is 6. Okay, standard form of a circle you have to memorize. X minus h squared plus y minus k squared, quantity squared, equals the radius squared. This is just kind of a dumb problem. The center is hk in this form. So they said, what is the standard form of the equation whose center is hk? Well, you just leave the hk in. Y minus k squared, and the radius is 6, so it's just going to be 6 squared. That's your answer. See that, John? Okay, your center is hk, so instead of, you don't need to put real numbers in here because they don't give you real numbers, so you just leave the hk in. It's a dumb problem. It's really dumb. Like if they would have said your center is 1, 2, you know, you would just say x minus 1 squared plus y minus 2 squared equals 6 squared. See that? Like if it's your center, you're just substituting, but they're telling you it's hk, so it's kind of weird. Okay, let's go to another board. I'm having trouble keeping my boards clean. Okay, 14, let's go to 18. Okay, these are all John's, right?
I don't think I got this one.
These loggies are so fun. Logs are actually on the ACTs. Plus log.
Wait a minute.
I'm an ACT fanatic right now. Yeah? Okay, well we'll do it anyway.
This is my problem.
Okay, it's Reese's, even though it's black. It's black on there. But
Well, my color is real close to black.
okay. Yeah, it's tricky. Okay, so anyway, if you have a number in front of a log, it pops back on top as an exponent. So that's why that 3 went there. 25 can be written as 5 squared. Whoops, I forgot my base. 25 would be written as 5 squared. So you want to take and if the number is a perfect square, you want to write it as an exponent. Okay, so this one's going to be log base 3 of, okay, this is where it might get a little bit tricky. What, John? No. What number are we doing? 18?
Is it 3 to the negative 1?
Yep, because you want to not have a fraction, so you want to put it as 3 to the negative 1. And then the last one is just going to be plus log 10 to the 1. There's nothing you can do with that one. Okay, now if your base matches this base, if the two bases match, they kind of cancel each other out and you just get 3. The bases match, so you're just going to get 2. The bases match, so you're just going to get negative 1. And log base 10 to the 1 power, you just know it's 0. Do you guys know that 0? The way you can set it up is you can set it equal to x. So 10 to the x equals 1. Well, what to the x power gives you 1? It has to be 0. And so then all you do is you put those all together and you get 0. That's it.
Cool.
These are fun. These are fun. You have to try to get your your two bases to match. Like try to do whatever you can to get the bases to match. So you could have written 1 as 10 to the 0 power, right? See how you could do that? And then the two bases match, and then you just take the exponent. That's kind of a cool way to do it. I like that. Okay, I like log problems. You guys don't ask me to do many of them, though. Seems like that. Yeah. All right, so John, this is another one of those. 22 is another one of the determine whether they're inverse functions. So you get f of x equals 3x plus 1, and g of x equals 1/3 x minus 1/3. Well, let's just do one part of it. Let's do f of g of x like this. So we get f of g of x. I'll just go fast. F of g of x. So you get f of g of x is 1/3 x minus 1/3. And then you go to the f function, and you put this in where the x's live. So you get 3 times 1/3 x minus 1/3 plus 1. So we put that in here, this. And then when you distribute it, you're going to get x minus 1 plus 1, and you get x. And that's how you're going to get x for g of f too, and so they're inverse functions. You get it when you put something in one and then put it in the other, it comes out what you started with. That's why they're inverse functions. 22 and 30 is a crazy problem. Let's give that a whirl. So let me scroll this up. All right. 30 is a triangular thing like this. That's really bad. Shoop. Okay, that's a right angle. And we have 3 angles that are the same right here. Whoops, that should have went up there. Whoops, it's really bad. Let me just start over. That's so bad I can't look at it. Okay. Let's see, we need a right triangle. I think I have a triangle tool. Oops, doesn't draw the right kind of triangles. Darn. Okay, I can at least draw straight lines. So we have a line there. We have a perpendicular line there. We have a line coming down here, like that. And we have another perpendicular line, another right triangle, and a line this way, and a line this way. That's much better. Okay. All right, so you have, this is your 30, 60, 90 triangles that you're dealing with. So you have a right angle here. These are all the same. Whoops, did I draw too many? I drew an extra line. Okay, this line shouldn't be here. So x degrees. So that means all of these are going to be 60 degrees. So all your x's are really going to be 60 degrees. So this is going to be 60 degrees here. This is 60 degrees here, and this is 60 degrees. So if those are all 60, then we know this one has to be 30, right? Because if you subtract it from 180, and you know this one has to be 30, and this one's 90, so this one has to be 30.
Those two.
This is equal to 8 right here, all right?
Yeah.
So you can figure out this side, because this is, if you're talking a 30, 60, 90 degree triangle, this is 30, 60, 90. If this side is 2, this is 1, and this is the square root of 3. So the 30 degree side is always half of the hypotenuse. So this is your 30, if you're looking at the really big triangle here, the 30 degrees, if you go opposite that, it's going to be half the hypotenuse, and so that's going to be 4.
Okay.
And that's how you can tell that's true. Okay, we're in the last problem. Heading down the last few minutes here. I hope you guys are asking enough questions. Is there any types you're not getting that you need to know how to do?
I don't know. I just look at the problem that I can't get, and then I just accept it and remember to do that again.
So are you leaning too heavily on the solutions book, John?
I don't know. After I do it, after I keep looking at the solution,
Yep.
I can remember it. Then the next time I do it, I won't.
You're
do what they did.
Well, that's good. Okay. Yeah, you have to use all your tools. I mean, that's going to be part of your life at college. Is they're not going to be spoon feeding you. A lot of times they're just going to send you home and you have to like figure things out yourself. Go on the internet, whatever it takes. You have to be self-learners. So hopefully this is helping you for that because you're kind of learning it on your own. Okay.
Yep.
So here you need to find out the complex roots. Did I copy this right? This is number 11. Factor, so you're going to have to factor it. So what we're going to end up doing is having two factors. Now, you could try factoring it, but it doesn't factor, and because it says complex roots, we know we have an issue. So first thing you want to do is take out the 2, so you get x squared plus 2x plus 2, and then we put it in the quadratic formula. So you get x equals negative b, so it's negative 2, plus or minus the square root of b squared, so it's 4, minus 4 times a times c all over 2 times a. So you're going to simplify this. Let me just look in the book so I don't have to do it all. Which lesson are we on? 47, number 11. So you're going to simplify all this, and so you get negative 2 plus or minus the square root of negative 4 minus 8 is negative 4 all over 2. So you're going to get negative 2 plus or minus 2i all over 2. And so you're going to get negative 1 plus or minus I. So this is one of the factors. This is one of the factors when we go to put it like this. But you have to subtract it from x. So it's going to be x minus something, x minus something. We factored the 2 out, so we're going to have to put the 2 out there. So your two factors are going to be x minus negative 1 plus I, and then the other one's going to be x minus negative 1 minus I. So what this is doing is it's really just giving us the two numbers to put here. You still have to finish it out, so you get x equals x plus 1 minus I, and then x plus 1 plus I. And that's how you would factor that. That's crazy, isn't it?
Where do they get the second 4 under the radical, under the first radical?
Whoops, hold on a second. This 4?
Yeah.
Uh-oh. Oh, because it comes with the equation. Negative b plus or minus the square root of b squared minus 4 times a times c. Yeah,
I just realized
all over
I keep
2a.
writing the negative 4, and that's why I keep getting these problems wrong.
Yep,
Negative sign.
yep, negative 4. So you have to have that formula memorized, and that's how you do it. So how did you guys do? I have a couple more minutes here. How did you do with the number 1 on that, the 4-digit counting number that doesn't repeat?
Failed.
You failed?
Yep.
How many 4-digit counting numbers? I just kind of like these now. So 4-digit counting numbers. How many 4-digit counting numbers can be made from the digits 1, 2, 3, and 4 if 2 and 3 have to be next to each other and repetition is not permitted? Huh. Did you get this one, Risa? Okay, let's try that one. These are tricky. They're like, I mean, they even say it in the book that these are tricky, but let's try to.
I was going to put this on the help board.
And why didn't you,
Why
John?
didn't you?
Because I did this today.
Oh, okay.
Why didn't you do it yesterday?
Good question, Risa. My fault.
Okay. So remember how we did the books? The books had to stay next to each other. So we did 2 ways they could stay next to each other. You could either have the 6 books together, then the 4 books together, or the 4 books together, then the 6 books together. This one's a little bit trickier because you have 4-digit counting numbers, and it says that the 2 and 3 have to be next to each other. So if the 2 and 3 have to be next to each other, how many different ways can the 2 and 3 be next to each other? So you could have the 2 and 3 be here and here. You could have the 2 and 3 be here and here. You could have the 2 and 3 be here and here. Is there any other places they can be next to each other? Oh, you could have, okay, you could have them, and then you could have them all reversed. You could have 2, 3, and then you could have 3, 2, right here and here. And then you could have, whoops, what did I do that for? And then instead of having 2, 3, you could have 3, 2. And then the last one, and then you can have, yeah, but we're not done yet, okay? Or we could have 2, 3 here, okay? All right, that's the 6 different ways that 2 and 3 can sit next to each other. But even just sitting next to each other, the 1 and 4 can be in different places, right? I mean, this one's not horrible. This one you don't even use the thing. So you can almost just write those out. So it's 3, 2, then you could have a 1, 4, or you could have a 3, 2, and a 4, 1, like that. So it's going to be 12. So each one of these, you could have 4, 3, 2, 1, or a 4, or a 1. This one's totally different. 1, 3, 2, 4. And then you could have this is your 2, 3 right here, 2, 3. So you could have a 1, 4, 2, 3, or a 4, 1, 2, 3. And then we could have our 2, 3, 4, 1, and our 2, 3, 1, 4. So this one you just kind of have to list them all out. And this would be our 1, 3, 2, 4, or our 4, 3, 2, 1. And then we could have our 1, 4, 3, 2, and then our 4, 1, 2, 3, 2. So it's 12 different ways. Okay, that was weird. That wasn't nearly as fun as what I thought it was going to be. So anyway, John, do you have any other ones in lesson 47 since you apparently didn't list them?
Not yet. No.
So you didn't do this lesson yet, so you don't know.
I did part of the lesson. I was trying to finish it before the class started.
Okay. All right. So I'm just looking over there. Risa, any that you didn't list that you didn't get on 47?
No.
Okay. So this week coming up, you're going to do 48 is not too bad. It's powers of trigonometric functions. If you were getting the ones like number 15, these should not be hard. All right, that's an easy lesson. Well, there's perpendicular bisectors. There's always more than one thing in a lesson. 49 is logarithms again. We're going to be, yeah, that's not bad. That's a short lesson. 50 is trigonometric equations, which is really fun. And then 51 is more logarithms. So this is a pretty good week. It's not so bad. So it'll be our last week of work before Christmas break.
So don't do any abstract rate problems.
Yeah, you can skip the abstract rate problems. We're not going to do those. Okay? Yeah, you can try them if you want to, if you have nothing else to do. So, okay. All right, well, we will end class, and next week we'll review for the test, and then I'll email you the test. All righty? All right, we'll see you then.
What
concert are you going to? What night?
Saturday.
Oh, just wondering.
Yeah, are you going, John?
I'm in it.
Oh, really? What are you doing?
I'm not, well, the finale.
Oh, really? Are you? Oh, you're in the choir? Nice. Good.
We have a practice tomorrow for the last practice.
Wow, fun. Well, good. All right. Well, we'll see you guys next week. Enjoy your week. Okay, we'll see you, John. All right. See you, Risa. Bye-bye.
Bye.